Welcome to Sao Paulo, Brazil, the biggest city in the southern hemisphere, one of the many places my day job flying the 777 takes me to. We just crossed the vernal equinox, so it's the beginning of fall down here in the southern hemisphere, and of course the beginning of spring up north. Let me check my date and time close. That's why I have such a hard time with dates and times. It's Tuesday, the 21st of March. So we had some heavy rain last night back in Northern California with more rain in the forecast. Let's go get the update on the real-time numbers of what's going on up at the Oroville Reservoir. I've got a lot of new footage to share with you, some good drone footage that the DWR, Department of Water Resources, captured with their drone. And with that footage, we can talk about some of the repairs that are going on, the cost of some of those repairs, and talk about this idea of rock bolts and how they work. So let's go check out the latest on the Oroville Dam. Just love watching these bikers do their lane splitting. Fearless city riders. By the way, if you get bored and look for something to do on YouTube, check out Brazilian motorcycle police chases right here in this city. Just some stunning, amazing footage. It'll keep you entertained for hours. Just can't get enough of that local music played right here in town, Sao Paulo. All right, let's look at the real-time numbers. They have lowered the lake significantly. Remember when they first turned on the spillway, it was about 865 feet, and now we're below 850, down around 848 right now. So we're below the flood control level of 850 feet. And they're going to continue to lower this lake level down to about 835 feet. Remember, that's the level in which they start to scour the inlet to the main spillway, so they'll probably shut it off right around 835 feet. Good news, they got the Hyatt power plant back online shortly after they reopened the main spillway. So 40,000 CFS is coming out of the main spillway, and about 5,000 to 6,000 CFS is coming out of the Hyatt power plant, for a total of about 45,000 or 46,000 CFS. So good news, they got the Hyatt power plant up and operating. They got that, the elevation of the Thermalito diversion pool is steady at 232 feet. So 232 feet allows the exhaust ports from the Hyatt power plant to remain open and clear enough to operate. Remember, you don't want to plug up the exhaust ports of your power plant, or you'll have a Russian dam type disaster that we'll find here on YouTube. Look up the Shushin. I can't pronounce that, but look up that accident right there in Russia. Here's footage of the Russian dam disaster when the discharge ports got plugged up and one or more turbines began to fail due to excessive pressures, resulting in flooding of the power plant and the loss of 75 lives. And there's the folks running for their lives out of the power plant as flooding occurs. And there's the turbines literally getting blown out of their mountings. And here's what it looks like inside the power plant after the turbines blew out of their mountings, flooding the power plant and shorting everything out. This is why you can't have the discharge plugged up to your power plant. This is why you got to preserve your power plant at all cost. That's why they did the precaution of shutting down the Hyatt power plant when they first started releasing water from the recently busted main spillway. Remember also, you have to have power to your power plant in order to turn the turbines. You cannot allow the turbines to freewheel without power to maintain the RPM of the turbines. They'll just spin up too fast and just get destroyed. So river releases, they're pouring some of the water into the Thermalito forebay and afterbay complex, and the most part of it right straight back into the Feather River at the diversion dam, but total releases are about equal to the outflow from the reservoir, about 46,000 CFS. Rain, yeah, it's raining there right now, and let's take a look at that weather. Inflows, because of that rain, is cranking up all the way back up to 40,000 CFS. So inflows are beginning to get close to outflows. But this weather, I'll show you, is spotty in nature and will not be a continuous downpour. Typical spring-like conditions, we're getting heavy downpours, almost thunderstorm-like activity in Northern California as this front passes through. But it's not the steady pouring rain that we've suffered from before. So these heavy showers can be absorbed by the watershed and will result in high inflows for a brief period of time. Snow level about 6,000 feet. And here's the radar loop as it moves over Oroville Reservoir and up into the Feather River watershed. Here's the 7-day forecast with precipitation right now resulting in a snow level about 6,000 feet. Then more rain and snow Friday and Saturday. So good breaks in the weather as we move through the week. So what does all this mean? With a lake level of 848 feet and dropping, there's plenty of flood control space left in Oroville Reservoir to handle the spring-like weather conditions that we're experiencing right now. With a steady 232 feet elevation in the Thermalito diversion pool, that means the Hyatt power plant can continue to operate safely without risk or fear of plugging up their exhaust ports or discharge ports from excessive debris filling up here as a result of the busted spillway. Just a quick recap of how we got here. Remember back on February 27th, they shut off the flow of the main spillway with a lake level at 850 feet. That allowed crews about 2 weeks' time to remove this all this debris that had blown out of the main spillway. Not all of it, but they removed a million cubic yards worth of this debris before the lake level filled back up to about 865 feet, and the operators were forced to turn this main spillway back on just a couple days ago. Now they're operating the main spillway at a fixed rate of 40,000 CFS. That's the optimum rate of flow to keep water flowing off the edge of the busted spillway without creating excessive erosion further downstream. And they'll be able to run that, they'll be forced to run that rate until the water level drops down to about 835 feet, at which time they're going to start scouring the inlet and be forced to turn off this main spillway. In the meantime, crews are able to continue to clean out debris down here in the diversion pool, which we'll look at. And operators may have to do this cycling on and off of the main spillway again as many as 2 more times this spring season. In other words, operators have lost basic throttle control of this main spillway and are forced to operate it on as an on-off switch at 40,000 CFS between 835 feet and about 850 feet on the reservoir elevation in order to get through the spring runoff season. There's no time to get in there and begin the overhaul or repair or rebuild of this spillway at this time. We're stuck in this pattern until we get through the spring runoff season. That being said, crews were able to do some temporary repairs while the spillway was turned off for the 2 weeks that they were removing debris. And let's take a look at that next. First, I want to go back and look at some of this archival footage from around 27 February, shot by one of the live helicopters. When they shut down the spillway, and this helps explain why we're stuck in this between a rock and a hard spot on the throttle capability of the spillway. As they shut the gates down, shut the water flow down, there's where you get your head cutting erosion that they're so concerned about. See on the left side of the spillway? And that's an area where they've put quite a bit of repair effort into, temporary repair effort during these 2 weeks that the spillway's been turned off. There on the left, you can see the concerned operators checking out closely the erosion that's happening as the water flow decreases. Now let's fast forward to 17 March. I think this is CBS footage. You can even hear my old alligator mouth in the background. She was very close to where I was standing with a good telephoto view. You can see the shotcrete repair on the left side of the spillway and the water approaching the Rockbolts. See the mist and water and spray of the spikes sticking up from the ends of the Rockbolts? We'll talk more about those later. Now, if she'll just zoom out a little bit, we can catch the whole picture. There you go. Quickly ramping up the flow to avoid further head cutting erosion of the busted spillway. It took them about 50 minutes to crank it up from 0 to 40,000 CFS back on the 17th. Here's the drone footage put out by the Department of Water Resources, and I spoke with the drone pilots the day I was there, and the Department of Water Resources closely monitors what footage is released to the public. And you'll see here, we start with the water coming down the spillway, but they don't show the best part where the water is pouring over the edge of the spillway and the anchor bolts or the rock bolts in action, or any of the minor erosion starting there at the head. Now there's a good 40, 50,000 CFS plunging straight down into the plunge pool. Again, the Hyatt power plant was shut down out of an abundance of caution during this operation, but once they determined the amount of debris and the stability of the water level in the Thermalito diversion pool, the Hyatt power plant was started back up fairly soon after this operation began. Looks like a motorboat wake as the water departs the spillway gates. And there's your newest waterfall feature in Northern California, the busted Oroville main spillway. This footage goes back to the 10th of March and helps explain some of the cost of some of these repairs. Those are Siller Brothers helicopters, the Sikorsky Sky Cranes, based out of Yuba City, California, moving the power transmission lines into place for the new transmission line, so they no longer have to run the power lines over the emergency spillway. They're going to create a whole new power line system. They These helicopters are expensive, somewhere up around $10,000 an hour. Here we're looking down the spillway and you can see the drill rigs for the Rockbolts. All that orange fluorescent spray paint is showing operators where to put the Rockbolts. Rockbolts to literally bolt the spillway back down to the bedrock. We'll look at how these Rockbolts work here in a couple of minutes. And here's your newly formed plunge pool right off the end of the busted spillway. Where's all the debris being taken coming out of the diversion pool? Well, right up here to these large benches around the edges of the emergency spillway newly formed canyon. Here's what's left of the lower half of the main spillway, and one of the first things they're going to do when they rebuild or repair this spillway is remove that lower half section altogether. There's another look at the plunge pool and the size and scale of it. There's your rebar. And a nice look right down into the plunge pool. Some of the repair work done on the edge of the spillway, shotcrete. So this is how they get the equipment down into the spillway to do the rock bolting with this crane. Here operators are getting the small drill rig into position to drill in another rock bolt. These rock bolts are commonly used in mining applications as well. Drill up into position and start drilling. After these rock bolts are epoxied into place, some of the ends of these rock bolts stick up above the concrete, and that's why you can see them when the water pours over the edge. And those ends can act as indicator pins as well, as we'll see here in a minute. Here's a good animation showing how these rock bolts are installed using the hollow shaft, self-drilling anchor bar, and the drill bit with holes for the grout to flow out the top. Mounted in the drilling machine. Hammer drill it through all the rocks and the voids in the rocks. Then remove the drilling machine, bolt it up, and hook up the grout machine, or the grout pump. Pump the grout through the hollow core, up over through the drill bit, and into the voids of the rocks, which gives you a very strong connection. Some of these biggest anchor bolts or rock bolts, some of the largest ones available on the market, are capable of forces upwards of over 600,000 pounds. Here's an example of them being used in a mining application where the ends can act as an indicator pin indicating movement. So that explains what we see sticking up out of the concrete here at the end of the spillway are the rock bolts in an effort to keep this end of this spillway together, and from further deterioration while we get through this year's spring runoff event. Coming up next is a good look down the Plunge Pool and the newly formed canyon with geologist John Curlis.
We're at the bottom here of the Oroville flood control spillway, and we're in the area where it was eroded after the spillway broke. What we do is we'll map the rock types, the shear zones, essentially the good, hard, fresh amphibolite here versus the weaker, more fractured and sheared rock. The most important thing that we're doing out here as geologists is observing and reporting in a timely manner, having the base maps that we can show people where we're at, and that's the construction people or the incident command folks, and giving them the opportunity to make a quick decision. Everything that we have at our disposal, from the drones to the LiDAR, helps speed things up. We can have a turnaround on a base map in a day, and that allows us, the high definition really allows us to be able to say, this is the rock I'm standing on, or there's that landslide that I'm worried about. We can map that out. We can see the shear zones running through here, map those out, the rock types, where certain things broke, and have a good base map that covers that. So interpreting what we see and being able to convey that to the decision makers here.
Capturing that data, that's going to allow engineers to determine how best to repair, rebuild, or restore this spillway in the future. And it'll show them how much this wears down in between each time they flow the main spillway. Now, this footage is from yesterday, 20 March, and it shows how the power plant flow is helping to keep debris clear here in the Thermalito diversion pool. Meanwhile, crews are still able to continue to clean up the debris. I know all you gold bugs are just chomping at the bit looking at that ore there, but they really do not have the time to be fooling around looking for gold, and besides, it's just not that productive in this metavolcanic rock. Here we see some hydro seeding operations going on along the newly formed canyon along the emergency spillway. So that's your 21 March update on the Oroville Reservoir and spillway situation. Things to look for in the near future is how much damage will the spillway suffer, will we be able to see once they shut down the spillway after this spill, and how much more debris ends up in the Thermalito diversion pool. But it looks like they got things under control for the moment here at Oroville, and thanks for watching. And remember, if you're not watching this video on the Blanco Lirio YouTube channel, you're watching the wrong channel, such as the fact of life when you're famous, I guess, is people just steal your data and put it on their own website. Thanks for watching. Stay tuned, and in 2 weeks' time, we're going to see what is going to be the winning design to repair, rebuild, or temporarily repair this spillway to get us through the next rain season. And will there be enough time this summer to completely rebuild this spillway? I don't think so. Stay tuned.